Assalamualaikum warahmatullahi wabarakatuh. I'm Ismail bin Ismail, metric number 1202572. Today, I want to present about the question 3, which is in the assignment of mathematical statistics, SMG 3013. Question 3 is talking about suppose S1 until Sn are independent identically distributed with probability density function, which is fx to the theta is equal to 1 over theta times exponent power of negative x over theta, where x is between 0 until theta. In this question need us to find the MLE, or we call as maximum likelihood estimate of probability, where x is at most 2. Okay, before we focus to the solution of this question, there are 5 steps that we need to apply to solve this question. Step 1, which is likelihood, the function of PDF, which is function of x to the theta. So the first step is the likelihood, the function with multiplication, the function of PDF. And then we subs the function of PDF to the equation. So we get multiplication times 1 over theta times exponent power of negative x over theta. After that, we should to expand the multiplication to the every variables in this equation, which is theta and the x. So we get multiplication times theta power of negative 1 times multiplication times exponent power of negative x over theta. So we get theta power of negative n bracket exponent power of negative x1 over theta until exponent power of negative xn over theta. So, as what we know, this is the summation of the x. So, we just write like theta power of negative n times ESP, or we call as exponent bracket negative theta power of negative 1 times summation of x. We continue to the step 2, which is we just need to calculate the log likelihood function, where likelihood function we have the answer in the step 1, right? Which is likelihood function is equal to theta power of negative n times ESP, or exponent bracket negative theta power of negative 1 times summation of x. In this step, we have to log the likelihood function. So, we write as log bracket theta power of n times ESP bracket negative theta power of negative 1 times summation of x. After that, we expand the log to the every variables, which are theta and dx. So we get log theta power of negative 1 plus log exponent bracket negative theta power of negative 1 times summation of x. The final in this step is negative n bracket log theta is minus to theta power of negative 1 times summation of x, because log or we let as a ln. If we multiply with exponent, we will get the answer to the 1. Step 3. In this step, we should to calculate the first order derivative of log likelihood function with respect to the theta. So, we will start the equation like d over d theta is bracket to the negative and bracket log theta plus bracket negative theta power of negative 1 times summation of x. At the end of this step, we will get the final answer like summation x times theta power of negative 2 minus n times theta power of negative 1. Okay, step 4, which is let the first order derivative of log likelihood function is equal to 0. Hence, we calculate with start to the first order derivative of log likelihood function is equal to 0, where summation of x times theta power of negative 2 minus n bracket theta power of negative 1 is equal to 0, right? And then we max negative n times theta power of negative 1 to the right hand side. So we will be n bracket theta power of negative 1. After that, we max theta as a subject. So we write as theta power of negative 2 over theta power of negative 1 is equal to n over summation of x. And then we expand the fraction of the theta. And then we get theta power of negative 1 is equal to n over summation of x. After that, we have to power of negative 1 both sides to get the theta power of 1. So we will get the answer as theta is equal to summation of x over n, or we get the final answer like hat theta is equal to mean. Okay, we move to the final step in this question, which is step 5. In this step, we focus to find the MLE, or we call as maximum likelihood estimate of the function. In this step, we need to find the MLE when the probability of x is at most to 2. So, in this step, we need to use the integration to convert the PDF to the CDF. So, we just write, which is probability of x at most to 2 equal to integration from 0 until 2 of function dx, which is 1 over theta times exponent power of negative x over theta. After we integrate the function, we will get the final answer like negative 1 over theta times theta bracket exponent power of negative x over theta. Before we integrate the range of integration, we have to expand the theta, which is 1 over theta times theta is equal to 1. So we get the answer like negative exponent power of negative x over theta with integrate from 0 to 2. So after that we subs the range of integration like negative bracket exponent power of negative 2 over theta minus exponent power of negative 0 over theta. Okay, every power of 0 is will become to the 1. So the answer for the exponent power of negative 0 is equal to 1. In the final answer of this situation, we will get the 1 is minus to exponent power of negative 2 over theta hat. Since we have calculated the theta hat where is equal to mean of x, we just subs the mean of x to the equation. So we get 1 over I'm so sorry. 1 minus exponent power of negative 2 over mean over x. So hence, the MLE when probability of x is at most to 2 is equally 1 minus exponent power of negative 2 over mean of x. That's all from me. Thank you.